Hello folks, Mr. Creed here. Doing my second video for the first day of notes for you guys. The notes you should be doing on tomorrow, Monday, March 30th. I'm going to go over compound events. Okay, compound events consist of two or more events. The last video talked about simple events. Okay, simple events was like rolling a dice or rolling a number cube, choosing a red marker out of a bag or a basket, or picking a number from a list of number tiles. Okay, those are all. It's just one event. Now we're going to talk about two events. Okay, for example, okay, I'm going to switch over to my camera here. Okay, let's talk about tree diagrams. Okay, tree diagrams are used to show what's called a sample space. A sample space is just a set of all possible outcomes of a particular experiment. Okay, so the experiment that we're going to see right now is involving 4 cards and 2 tiles in a board game. Okay, the cards are labeled A, B, C, and D. The tiles are numbered 1 and 2. A player randomly selects 1 card and 1 tile. What are all the possible outcomes? Okay, well, let's look right here. Here is our set of possible outcomes. This is our tree diagram. This is our sample space. Okay, I have 4 cards: card A, card B, card C, and card D. Underneath every card, you will see tile 1 and tile 2. Okay, it is listed this way because every card that I can choose, I can also choose a set. I can choose a particular tile. Okay, so if you look underneath here, we have card A with tile 1, card A with tile 2, so on and so forth. Okay, how many outcomes are in this sample space? Sample space again is including both the cards and the tiles. If we count 1, 2, 3, 4, 5, 6, 7, 8, all of the outcomes of this event, there are 8 possible outcomes inside this sample space. Okay, so another way that we can identify the number of outcomes in a sample space is called the fundamental counting principle, which is saying that I'm taking the number of outcomes for the first event and multiplying it by the number of outcomes for the second event. Okay, for example, in this first event, I have 4 different cards. In the second event, I have 2 different tiles. So to determine all the possible outcomes, I could just take 4 and multiply it by 2, which gives me 8 possible outcomes. Okay, this is called the fundamental counting principle. Okay, you're multiplying the first event by the second event. Okay, all right. So the probability of a compound event is to calculate that is listed below. So probability of some event, okay, is equal to the number of favorable events divided by the number of possible outcomes. Okay, so what is the probability of selecting a card labeled D in a tile number 2? So let's jump back up to our sample space. We can do this simply out of observation. Okay, look at the card D with tile 2. Well, how many times does that occur? That only occurs 1 time. There are 8 possible outcomes. Okay, so the number of favorable events, card D with tile 2, is 1. Okay, and possible outcomes is 8. So we're taking 1 and dividing it by 8. So the probability would be 1/8 or 12.5%, roughly 12.5%. Okay, so let's take that time now. We're going to actually, we can draw a sample space or we can use the fundamental counting principle. Okay, I'm going to show you the fundamental counting principle for 1 and 2, and then I'm going to show you a sample space example for 3. Okay, so you got to find the total number of possible outcomes of rolling 2 number cubes. Keyword here is a cube. A cube has 6 sides. A number cube can be numbered 1, 2, 3, 4, 5, and 6. An example of this would be like a dice. Okay, a dice for a board game like Monopoly. Number 1 through 6. Okay, so the probability of rolling one of those sides is one out of those six sides. So 1 out of 6 is the probability of for each side. Okay, but I'm not trying to find the probability. I'm trying to find the possible outcomes of rolling 2 number cubes. Okay, well, the outcomes of the first number cube are 6. I can roll 1 through 6. Okay, if I roll, those are my possible outcomes. If I do that twice, I have 6 outcomes for the first cube. I got 6 outcomes for the second cube. We're going to use the fundamental counting principle, taking the number of outcomes for the first event and multiplying it by the number of outcomes for the second event. In this case, 6 times 6 is going to be 36. So I have 36 possible outcomes when I roll 2 number cubes. Okay, for example, that could be rolling a 1 and rolling a 4. Okay, that would be an example of that. Okay, all right. So how many different outfits can you make from 5 shirts, 3 pairs of jeans, and 2 pairs of shoes? If I were to create a sample space for this using a tree diagram, we're talking about a lot of space being taken up here. So let's just use the fundamental counting principle. That would make sense. That would just make it easier, right? Okay. So 5 shirts, 3 pairs of jeans, and 2 pairs of shoes. So my first event is 5 shirts, second event is 3 pairs of jeans, and third event would be 2 pairs of shoes. Okay, so I can just take 5, multiply it by 3, and multiply that by 2. And I can determine the number of outfits I could wear for inside all this right here. Okay, so I'm sure you guys have more than that. If I could take it down to my closet, I can show you every pair of shoes my wife has. She has a lot more than one person needs, but nevertheless, we're going to say we're a pretty simple person, and we only have this amount of clothing. So we're going to take 5 times 3, which is 15, and multiply that by 2. Okay, we should be able to have 30 outfits with 5 shirts, 3 pairs of jeans, and 2 pairs of shoes. Kind of hard to believe, isn't it? But that is the case here. Okay. All right. So let's say you flip 3 pennies. What's the probability of flipping 3 heads? Well, can you tell me the probability of flipping 1 head if I take that first penny? Okay. Well, the probability of flipping a head on 1 penny is 1/2. 1 out of 2 chances, 50%. It's either heads or tails. Okay. So for each penny 1, penny 2, and penny 3, I can flip a heads or tails for the first one, heads or tails for the second one, and a heads or tails for the third one. Okay, so this would be like a sample space, but it doesn't really give me all the outcomes like I would think it does, right? So what I'm going to do, I'm still going to use the fundamental counting principle for this, even though I have drew a sample space or a tree diagram for this right here. Okay, so the probability of getting a heads for penny 1 would be 1/2. The probability of getting a heads for second penny would be also 1/2. And for the third, also 1/2 as well. So using that, I'm going to take that and I'm going to multiply all the way across. Okay, 1 times 1 times 1 is 1. 2 times 2 times 2 is going to be 2 times 2 is 4. 4 times 2 is 8. So 1/8 would be my probability there. Make sure you like this video, comment if necessary. Please, for my class, if you're listening to this or watching this, cut out this sheet, tape it or glue it into your notebook. If you have any questions, comment or participate in my Zoom meeting every morning from 8 o'clock to 10 o'clock if you have any questions on this. Okay, have a great day. See you guys later.